everyone, and welcome back to Technically Unsure, where I'm not really sure what I'm doing technically.
I am not sure yet.
Yet here we are. So today we are diving deep into the world of single board computers again, and boy oh boy, do we have a showdown today. So we are comparing the mighty Banana Pi BPI-M7, which just came out, with the legendary Raspberry Pi 5. So grab yourself a coffee, sit back, relax, and watch me struggle getting these boards to work. Basically install all the tools and benchmarking tools and all that. So let me show you the board. This is it. This is how it arrived, and I haven't had a chance to open it. So we are going to open it together. And on the box itself, it just says ARM Banana Pi and a new generation of mini PC. Nothing else. Okay, so we are going to open it, and it comes in an anti-static bag. Okay, beautiful, isn't it? Love SBCs, you can tell, right? Okay, so let's go over what's going on in here. So let me flip it over this way, and let's go from here. So from this side, we have the 2.5 gigabit Ethernet. Yep, you heard that right. Not gigabit, it's 2.5 gigabit each. And then next to it, we have a full-size HDMI port, and next to it, we have USB 3 ports. So both are USB 3.0. At least that's what I remember they were saying, even though this one is like black, but yeah, this is blue, but still they say both are USB 3. And on this side you have the typical 40 pin GPIO. I haven't checked the pin out yet. I assume it is similar or maybe even identical to Raspberry Pi, but yeah, we are going to check that. And next to it we have a Type-C USB OTG USB-C connection here, and here we have USB-C, but this is only used for powering the board, nothing else. Fan connector is in here, and in the center, so we have these two are LPDDR4, so these two are the RAMs, and this is the eMMC. This is the, I believe, yeah, I got the 64 gigabit version, so I wanted to keep the field level, right, as much as I can. So I got the 8 gigabyte RAM version, but there is 16 gigabyte or 32 gigabyte versions of the board as well for the RAM. But as I said, I wanted to keep the field level as much as I can, so I went with the 8 gigabyte version for the RAM. The 64 gigabyte eMMC is here. I don't think they sell any board with no eMMC. So there are a couple options. I will put the link somewhere in the description. Go check it out. There are different configurations that you can choose from. And yeah, let's continue. So we have also here a Wi-Fi 6, that's what they're claiming, and Bluetooth 5.2, so that's also there. Yeah, so as I was saying, right, I bought the 8 gigabyte version. It costs, I think, around $165 US. So hear me out. This board does have the PCIe 3 on it, right? We're going to talk about that in a moment, and meaning you don't need this Raspberry Pi hat, right, which is 25 bucks. So say 85 bucks for the Raspberry Pi, 25 bucks for this, like 110 bucks for this, and this is 165. And the PCIe full size, I will check the site, don't quote me on that, but there is a PCIe 3. They are saying this is PCIe 3, meaning you don't need a hat for that. So for that extra 55 bucks, you are getting things that the Raspberry Pi 5 does not have, such as 64 gigabyte internal eMMC, 8K display support and 8K rendering support, decoding and encoding, triple display support with HDR, 2.5 gigabit Ethernet, 6 TOPS NPU, TOPS like a trillion operations per second. So this does have a built-in NPU, and also an extra 4 ARM cores. And as I said, the built-in PCIe 3, in here. There is also the operating temperature difference, which is this one goes from 0 to 80 Celsius, and I believe Raspberry Pi Max is 60 operating temperature. There is also, before I forget, let me rotate this. So here we have the SD card slot, and then next to it we have the DSI slot, so MIPI DSI display, and two MIPI CSI ports for the cameras. So you can connect the cameras and displays, SD card, PCIe, and that's it on the back. There's nothing else here. So honestly, from what I see and what I'm reading on paper, in terms of specs and capabilities, the extra $55 is very well worth it. As the president of Trickle Down Economics said, now trust but verify. So we are going to do just that. I'm going to verify the claims: 2.5 gigabit Ethernet, the Wi-Fi 6, performance of the Rockchip, and as much as I can. I'll also try the GPIO and the official images and everything. We'll see what I can get it to work, and most importantly, the PCIe 3 this built in. I want to make sure that this actually works. So let me wire up this board, put some heat sink on these, and put some fan in here. This didn't come with anything, so I will see what I can find. And I saw like Banana Pi some videos of this board. They are running it as is, no heat sink, no fan, nothing. I guess you can do that. I don't want to do that. I will try to do something, cool it at least a little bit. So anyway, I will be right back. Okay, so here's what I got. I placed a bunch of heat sinks on it, and yeah, I know it's not perfect, but it will get the job done. And I have installed an SSD in here, and then the heatsink in here. And I'm going to borrow the same hat that I used on the other boards as well and install it in here, so it will blow air as well on it. So that's pretty much it. Here's the deal. Without even inserting the SD card, I tried to boot, and it actually boot right into a Chinese Debian. So I want to show you that before proceeding. So I'm going to connect the Ethernet, connect the HDMI cable, and by the way, on this other camera you are going to see this power consumption. So as soon as I plug this in, you are going to see the power consumption, and also check the boot time. So 3, 2, 1, go. So it's using the 12 volt input via the USB-C, and it's around 0.3, 0.5, 0.6 amps. So there you go. We booted automatically into the Debian, and this is what you see. I didn't touch at all anything. This is what you will get. So there was one thing on the desktop. It looks like a desktop app of a script of some sort. I don't know if they wanted to keep this in here, but yeah, it says the production test, and these are the things that we talked about, the ports, so you can, I guess, select them. There is a camera test over here, and I assume this is display because this is the camera and this should be the display ones. I don't know. So yeah, these are the buttons, but I haven't connected any camera, so when you click on it, it just crashes. Just wanted to show you that. I looked around, and there is nothing else around here, but here's the deal. As you can see, it automatically, I did not install a firmware update, I did not do anything. It automatically detected the NVMe SSD. And if we do, let's go root. By the way, it doesn't have any password. So let's do simple first. So you can see that it was able to detect the Samsung NVMe SSD 980 Pro. So it's right here. And if we do, we already did dash VV. Let me just find the NVMe one. Okay, so here is the NVMe. Basically, it is able to read all data from it, and I did not do anything to it. It's just all on its own, no update even needed. Just wanted to show you that, and this is the speed it is claiming. We're going to test all that, but before that, let's do an F disk. What happened? Yeah, once we do F disk, you will see that this is the 64 gigabyte eMMC and the 2 terabyte NVMe, which is there. So I just wanted to show you this environment, and obviously if I try to do apt update, it is going to probably source apt sources list. Yep, it's all Chinese. So I just wanted to show you this. I am not going to use this because I can't read Chinese, to be honest. I don't know. And the mirrors are all already in Chinese. I'd rather just run an Ubuntu. So just wanted to show you this. I am going to now go read some documentation, figure out how to boot it from the SD card, because when you plug it in, doesn't matter, it still boots from the eMMC. I will be right back. Okay, so we are back. Unfortunately, I don't have a lot of great news. So no matter what I did, the SD card boot is not working. So I flashed all sorts of images that they are providing, and from those the getting started page, and absolutely none of them worked to, boot from the SD card. So what I ended up doing was actually using this, USB download tool, which you connect this to the second USB port in here, USB-C port, which is the OTG port, and connect it to your computer. Install the driver. I tried with Wine on Ubuntu, didn't work, so I had to switch to Windows machine and install this driver and run this app. And then basically using this app, I was able to flash a Debian, which ended up being the same Debian that it was already on the eMMC. I wrote it in the eMMC, flashed a brand new fresh copy, and let me show you actually what that looks like. So this is what it looks like. This is the device. So what I ended up doing was clicking on the upgrade firmware. I selected the Debian image in here. I also tried the Android, both works. So I selected the Debian image, and then basically I connected the OTG, and then I clicked on upgrade, and that was the only way I was able to flash into the eMMC internally from Windows. So after that, when you boot into the operating system with the Debian, everything is Chinese, as you saw initially. So what you have to do is dpkg reconfigure locale. So you have to do this, and you have to change the locale and change the languages, right? So I went down in here and found the ENUS. I selected this, and I deselected, which is the very last one, ZH for the G. Yeah, Mandarin Chinese. I'm sorry, I don't know. Whatever it is. So it was one of these was selected. I unselected it, clicked OK, and did a reboot. And even after that, in the bash RC file, there was some settings in there that to set the locale to, again, Chinese. You have to comment those out. So basically, if you do a nano.bashrc, you go all the way down, this is it. So I commented those out. It comes with it. If you don't do it, when you run a command, let's say apt update, it will just print out Chinese characters, words. So that's another thing you need to do. And one more thing you need to do is just update the apt sources list, and I switched to US. So you have to do all these things manually, and after that you're good to go, to be honest. So that was one of the things. Another thing I noticed is that it runs hot. So when I was doing a little bit benchmarking, it was going up. So we're gonna cover that as well. Let me show you a couple of things before that. So if we do, let's do a couple of benchmarks, like real quick. Let's do, oh, by the way, before that, I want to show you that Bluetooth is working out of box. I didn't install anything, it is working. And also Wi-Fi is working here. Yeah, the Wi-Fi is working, Ethernet is working, and it's 2.5 gigabit. So we're going to test that as well. That being said, let's start with maybe 7Z. Okay, so we are done here, and you can see the instruction per second and the speed in here. I believe it's very close to the other RK3588 based boards that we have, reviewed in this channel. So that's pretty much what, as I said, it is running a little bit hotter than the other ones. I guess the heat sink and this cooler is not that efficient. The other ones, the fan was blowing straight to it, but this is a little bit on the side. So that's all I could do for now. It is not affecting much the benchmark, but yeah, just wanted to point that out. Let's do a quick sysbench. Okay, yep, as you can see, 10,000. I'm getting used to this number. Raspberry Pi 5 or RK3588 based SBCs that we have been reviewing here all come around this number, so that's pretty standard. And let's test the 2.5 gigabit Ethernet and see if that is actually 2.5. I guess it is not. It's not bad, don't get me wrong. It's faster than a gigabit, but it's not 2.5 gigabit per second. Just saying. But still, it's very fast, to be honest. Remember, every time we're doing a gigabit Ethernet test, we are getting 7, 8. The best ones we're getting 900, which is exactly what it should be. So I was expecting more from this. Unfortunately, it is not doing that. So just pointed out. But remember, there you have two 2.5 gigabit Ethernets. Still, it's very good. That being said, let's do one last stress NG test. Okay, this one is, I think, a little bit slower side in comparison to the other ones we checked, but okay, acceptable. All right, 872. I have to check with the other ones, but that's the number. And let me show you the GL Mark II. I believe this one is actually slowest from the other ones that I have tested, but let's see. Okay, so the GL Mark score is 721. I was expecting more, as I said. So far, it's a little bit underwhelming in terms of comparison to the other RK3588C SoCs. So that being said, yeah, I mainly complain about the documentation stuff. As I said, no way to boot from the SD card, no way to boot from the eMMC. It shows the eMMC, it reads, writes, and you can work with it with the PCIe 3 speeds, but it does not boot from it. So that's a problem. I'm sure there is a way to figure this out, but there is no documentation. And as I said, I don't want to spend a lot of time just to figure it out. Another problem that I have is as soon as you remove the power connection and put it back, the time and clock settings is all gone. And I understand that's kind of expected. It doesn't have RTC, but would have been nice to, have a backup battery of some sort, or at least offer it. Now I have to figure it out on my own and put an external RTC to it myself. And that being said, now let's see how bad or how good is the documentation. So I just brought out the multimeter. So we are going to go to the GPIO section, and yes, just like Raspberry Pi, on the second part and third one is the ground. And let's confirm that first. Let's do with the first pin and make sure it is 3.3 volt. It's on this side. Yep, 3.3. So now let's play around. Let's choose this one just for fun. Pin 11. So from top, 1, 2, 3, 4, 5, 6. Let me count that. 1, 2, 3, 4, 5, 6. All right, did I put it in the right place? So I placed that in pin 11, and it says that GPIO is 113. Let's see if that is correct. So as you know from my previous videos, what you can do is echo 113 to sys class GPIO and export that. And next thing you do is you set the direction, GPIO 113 direction, and then we write 1 to the value. Yep, as you can see on the other camera, hopefully you can see it. Yep, you should. So it is now, the value is high, and if I set the value to 0, goes to 0. So that works, and I'm glad at least GPIO is documented properly. It looks like it. So if I open this up, yeah, the pins and everything is explained. The functions, multifunction pins, all functionalities are covered. The numbers and the physical GPIO pin is described here. When you have this, you can use not any, but you can use a lot of libraries to get the job done, right? And GPIO detect is always there for you to detect these things if you want to tinker around. The problem we had with HackerBoard was there is just no way. I brute forced my way around every single pin and GPIO chips, it wasn't working. As a serious problem in there. Anyway, so let me remove these. Okay, so I'm glad at least we got the GPIO working. The documentation is not bad, but the requirement to install the operating system from the Windows application, there is no Linux application for that tool that they are talking about in here. This one, there is no tool. That sucks, and the SD card boot just absolutely doesn't work, and I could not get it to boot from the NVMe SSD. So you can understand why people are going with Raspberry Pi 5 or boards like this. To be honest, simply it just works. right? I get it. This does not have two Ethernet ports. This does not have two 2.5 gigabit. It does not have maybe HDMI 2.1. That one is HDMI 2.1. It does have a CEC on that as well. It does have built-in PCIe 3. For this one, you need this FPC wire along with the NVMe Pi hat. I get it. I get all that. I get it. But it just works. Put an SD card, it works. You boot into the operating system, switch to the NVMe SSD, it boots from the NVMe SSD. And the images and the operating systems that you can flash into it just works. Yeah, that sucks in this case. And I believe even the Rockchip is not properly implemented in this Debian. I can show you. I'm sure it's not gonna play properly, but let's try. Okay, I take that back. All right, so yeah, this seems like it can play the 4K video without dropping any frames. So seems like the Chrome that was in the Debian actually is using the Rockchip. So that is good. Yeah, it doesn't have that problem. And the FFmpeg, as you know, FFmpeg does have apparently some licensing issues with Rockchip stuff. So you have to download the FFmpeg that is created for Rockchips in order to use the Rockchip. And yeah, no frames drop. That's great. So I believe we covered the GPIO, 4K video playback, 2.5 gigabit Ethernet, a Wi-Fi, Bluetooth, and let me put the NVMe SSD back and let's see the speeds that we are getting. So I will be right back. All right, we are back. So I installed the NVMe SSD and it's the 980 Pro version of the Samsung NVMe SSD, and this is the output of LSPCI-VV. So you will be able to see the capabilities and device speed and the link speed. So it seems like currently it's downgraded to X4, but what I did was I basically used this script to set the speed for the device. In order to do that, you just need to run that with the argument being the device number ID. So we just copy this, we paste that, and as you can see, current speed it says is 3. So we are apparently running at PCIe Gen 3. So current link was already 3 when I ran the script. So with that being said, I'm going to run the Jeff Geerling's script for benchmarking the SSD. So as you can see, it is benchmarking the NVMe SSD card. So yeah, SSD 980. It's not benchmarking the other one. So first, it is trying to do with the eMMC BLK. That's the internal device. Okay, so this is output for the eMMC. Let me show you. It was using, yeah, this device. That's not the NVMe. So it tried to do benchmarking on this device, and that's the boot device, and that's what we are getting. It's very, very fast, honestly, just for the eMMC. Now I'm going to run on the NVMe disk. Okay, so what I did was I moved to this folder, which is the NVMe SSD, and I will show you that. So if we do fdisk, this is the NVMe SSD. And if I do mount, you will see that the NVMe SSD is mounted to Media ARMSIM Writable. And we are in Media ARMSIM Writable and just the temp folder. So we are going to benchmark the PCIe now. Let's see. Okay, so we got the results, and it is very, very fast, to be honest. So it is faster than this, but also it affects that this PCIe is this tiny one, and it definitely is not as capable as the 980 SSD that's in there. So this one is not much information in here, but that one is using full-size NVMe SSD 980 Pro, but super impressive. As you can see, it is actually Gen 3 NVMe SSD. If only they had the proper documentation, I could have booted from that NVMe SSD, and I should have had, super fast boot time and everything else. But still, you saw the results for the internal eMMC, that is also still very impressive and very fast. So yeah, I just wanted to show you that it is actually PCIe 3, and so you don't need this Pi hat or anything like that to support it. Out of box, it works. The NVMe SSD works. So I'm torn. You know, the HDMI, the 2.5 gigabit Ethernet, it's working perfectly. The Chrome renders 4K video with nothing installed perfectly. NVMe SSD works with Gen 3 speeds perfectly. It's super impressive. Yet the documentation and the way that you can switch between the boot devices and how to even boot at all with the SD card is nowhere to be found. Whatever they're writing in there, whatever images they're providing, you try, you put the SD card in there, burn one of the images, just does not boot. I even did one thing. I destroyed the eMMC image, right? I did a DDIF and I basically wrote all over the MMC BLK device, the whole thing. I wiped it clean with IF being dev 0, input device and output was the whole eMMC. Wiped it clean and put an SD card, removed the SSD, installed the SSD with SD card, without SD card, absolutely does not boot. I don't know. And you look at it in the documentation, you know, in the starting guide or whatever it was, it just says put the SD card, burn it with the etcher, and then it will start working. It does not. Anyway, I think this device is extremely impressive for the $50 difference between this and that. I think it's very well worth it if the Banana Pi team ramp up their efforts in the documentation, examples, images, and everything else. Right now, it is still manageable. You can install the operating system on the eMMC and install an external SSD and use it that way. But yeah, it is extremely fast. I'm very impressed. So thanks for watching, and I will try to do that's my plan in the very near future. Stay tuned. Subscribe if you're not subscribed. So what I'm going to do is I'm going to put a bunch of these RK3588 devices that are claiming at least to be competitor to Raspberry Pi 5. So I'm going to put them together side by side and do a benchmark and comparison in terms of capabilities, I/O, and documentation, operating system support, and performance. So stay tuned for that. Anyway, thanks for watching, and I will see you in the next video. Bye for now.